In this video, we will be looking at trig ratios of any angle. Now, so far we've been doing trigonometry with triangles, which typically have angles, if it's an acute triangle, of less than 90 degrees. Or if you have an obtuse triangle, you could have angles that are somewhere between 90 to 180 as well. But if you play around on your calculator, you might be able to type in cosine of 220 degrees and you will get a value. So we're going to start looking today at how that happens exactly. So I have the x and y axis here, and I have different points drawn in the 4 different quadrants. And so those points all have coordinates, and I've drawn terminal arms to those points. So a terminal arm, remember, goes through the origin, and it's going to make an angle with the x-axis. So in quadrant number 1, which is in the top right corner, this angle theta is the angle we will be examining, because from the x-axis, that's the angle that is made with the terminal arm. All right, so I want to be able to calculate the trig ratios, all 6 of them, for this triangle right here that I've made. So I've made a triangle out of it, just like in the last video, by drawing a vertical line down to the x-axis. So I do have a triangle here. Now, as I mentioned in the last video, we call the hypotenuse r. Okay, so that r value does not have a positive or negative direction like these points will, and we'll get to that later. So it will always be a positive value. So first thing I can do is, I know that the x value of this point is 24, so I can label the base of this triangle as a distance of 24. Also, the height of the triangle will be 7, since that's the y value. So just like before, I have to calculate what the hypotenuse is. So r squared would be equal to 7 squared plus 24 squared. So I'm going through this pretty quick because you should know Pythagorean theorem by now. So what we get is an r value of positive 25. So there is my hypotenuse. All right, so now I can list all my trig ratios given this triangle right up here, so you can ignore everything else for now. All right, so starting with the sine ratio, so sine of that angle theta would be opposite over hypotenuse, so 7 over 25. Cosine theta would be the adjacent side, 24 over the hypotenuse, 25. And tangent theta would be equal to, we got opposite over adjacent, so 7 over 24. Now I can easily turn those into the reciprocal ratio, so cosecant theta would be then 25 over 7. Secant theta, the reciprocal, would be 25 over 4. And then cotangent theta would be 24 over 7, the reciprocal of tangent. Now, one thing these all have in common here is that all 6 ratios in this quadrant are positive. They're all positive values, and that's because your x value is positive always in this quadrant, and your y value is positive always in this quadrant. Now, in the top left corner, this is what we call quadrant 2. The x value is negative 7, the y value is positive 24. So my x value, I'm using negative 7 because it's gone 7 to the left. The y value is positive 24. And I've already calculated over here that the r value, the hypotenuse, is 25. So let's see what happens to the ratios in this case. So sine, and again, the angle that we're evaluating here is from the x-axis to the terminal arm. So sine of theta would be, so opposite over hypotenuse is 24 over 25. Cosine theta is adjacent, negative 7 over 25. And then tangent theta is opposite over adjacent, so 24 over negative 7. But let's be careful not to have any negatives in our denominator, so I'll change that to negative 24 over 7. Now, what you'll notice here is what these have in common, or what they don't have in common. Cosine and tangent ratios are actually negative, and the sine ratio remains positive. So sine is positive, but cosine and tangent are negative. And the reason for that is, if you notice that out of these values that we're using, the adjacent side is -7, so any of the ratios, which are cosine and tangent, that use the adjacent side will also be negative. So now that we have the primary ratios, we can quickly find the reciprocal ratios, and we'll see what happens to those. So the reciprocal of sine, so cosecant theta, so I can flip that, is 25/24, so it's also positive. The reciprocal of cosine, secant theta, would now be, if I flip it, and also making sure that the negatives in the numerator, is -25/7, so it is negative, just like cosine. And then the reciprocal of tangent is cotangent, and again with the numerator being negative, is -7/24. So when sine is positive, that means that its reciprocal of cosecant will also be positive. When cosine was negative, that means that its reciprocal of secant was also negative, and same thing with tangent and cotangent. Now the reason for this is, if you're finding the reciprocal of a number, all you're doing is flipping it, so nothing's going to happen to the sign. The sign will stay exactly the same. In the bottom left corner, we have what we call quadrant 3. So if this point here is -3, -4, gives me an x value of -3 and a y value of -4. So I've labeled those. Now I've already solved over here for the r value, which is 5. So let's see what happens to the trig ratios for this triangle right here. So this would be my 90-degree angle, and this is the angle theta, because that's from the x-axis to the terminal arm. So sine theta would be opposites over hypotenuse. So you actually see that sine is negative in this case. The cosine of angle theta would be adjacent over hypotenuse, so -3/5. And the tangents would be opposite over adjacent, so -4/-3. Now, these two negatives, if you divide negative by a negative, remember they cancel out, so we actually get +4/3. So what you can see in this quadrant is that tangent is positive, but sine and cosine are negative. Now, just to speed things up, I'm not going to show the reciprocal ratios, but if you flip them, the reciprocal of sine would stay negative, reciprocal of cosine would stay negative, reciprocal of tangent would stay positive. Now, in the last quadrant, quadrant 4, this is in the bottom right-hand corner, so 8, -15 are the coordinates. So my triangle has a base of 8 and a height of -15, so I can draw a 90-degree angle there. And this is the angle theta that we are measuring. So I've calculated over here that the r value, or the hypotenuse, is 17. So let's take a look at the ratios. So sine of that angle would be opposite -15 over hypotenuse 17, which is negative. Next we have cosine of theta is equal to, we have +8 over 17, and that's positive. Then we have tangent of theta would be -15 opposite over +8, which is going to give us a negative ratio. So in this quadrant here, we see that the cosine ratio is positive, but sine and tangent are negative. And the reason is, in this case here, the only negative side that we have is -15, which is the opposite side. So any of the ratios that use the opposite side would then be negative, which is tangent and sine. And I didn't mention it the last time, so for quadrant number 3, we have -3 and -4. That's your adjacent and opposite side. If you're only using one of them, like in sine and cosine, that gives you a negative ratio. That's why those are negative. But tangent ends up being positive because you are doing the ratio of two negative numbers. All right, so what we've discovered here is that in quadrant number 1, all of the ratios and all of the reciprocal ratios are positive because your x and y values are positive. All the numbers are positive. But in those other quadrants, you're only going to have one ratio that is always positive. So here's something that you can remember. I'll put an A for all in quadrant number 1. sine was positive in quadrant number 2, so I'll put an S there. T for tangent in quadrant 3, C for cosine in quadrant number 4. So an abbreviation that people like to use is the CAST rule, if you look at it in that direction, C-A-S-T. Or by starting in quadrant number 1, you can remember all students take calculus. And that's how you can remember in which quadrant each ratio is positive.